several students had emailed me about some of your homework problems involving applications. And I'm in the process of grading your homework, but on the off chance I don't get your homework graded before your exam opens tomorrow, I wanted to run through the solutions so you could see them written out long form to make sure everybody is clear on what's going on. So I'm just going to use my book here and go through them. I may not actually do the algebra at the end to solve them because I think the issue is the actual setup, creating the variables and creating the equations. The algebra is then just distributive property and button pushing on a calculator. So that part should be fine. It's just the setup that matters. So this is page 89. And we're going to do first number 8. And we're told Ebony bought a 5-year treasury note that paid the equivalent of 2.8% simple interest. She invested $5,000 more in a 10-year bond, earning 3.6% than she did in the treasury note. If the total amount of interest from these investments was $5,300, determine the amount of principal for each investment. So first we say, how many quantities am I looking for? I'm looking for the amount invested in both accounts, so I need 2 variables. But we understand that if I use 2 variables, I need 2 equations, and that's more complex. So I want to try to do it with 1 variable. So I pick one of the accounts and call it X. The first account was 2.8% simple interest. So X equals the money in the 2.8% account. Then we're told she invested $5,000 more in a 10-year bond, earning 3.6%. Now I have to find a way to relate that to the first quantity. But we're told she invested $10,000 more in the second account, so I take my first account and I add $10,000 to it. That has to be the money in the second one is 3.6% account. Now I'm told, well, I guess I have my variables. I need to generate an equation. The only other information we haven't used is the total amount of interest was $5,300. I have to use that, so I can just write it out. Where does my interest come from? Well, my interest comes from the first account and the second account. Now it's just the interest formula. Interest is principal, which is X for the first one, times rate, which is 0.028, times time. And in this case, you're told the first account is a 5-year treasury note, which means time has to be 5. That's the interest from the first account, plus the principal for the second account, X plus 10,000, times the rate, 0.036, times time. The second account, you're told, is the 10-year note, so time is 10. And now you have an equation, and it makes sense. Interest from the first account plus interest from the second account equals total interest. I'll leave the algebra to you. Just remember, for this one, multiply these together first, then distribute in, and then go from there. Good. Now, number 10. A nurse mixes 60 cc's of a 50% saline solution with a 10% saline solution to produce a 25% saline solution. How much of the 10% solution should he use? You're told to find one quantity, so that can be X. The amount of the 10% solution. That's what I want, right? The 10%. Now with that variable, I need to create an equation. And one of the good things about these mixture problems, they're identical to the interest problems. The variable setup works the same. I still have percentages. Still looking for the amount of a percentage, principal with a percentage. And the equations essentially work the same. Here I had interest from first plus interest from second is total interest. I can do the same thing here with my mixture. Mixture from first plus mixture from second equals total mixture. So then I figure out, let's see. A nurse mixes 60 cc's of a 50% saline solution, so the amount is 60, times the percentage, which is 0.5, that's the first one, with a 10% saline solution, so the percentage is 0.1. How much of that did I add? Well, I don't know. That's my x. That's what I want to know. Amount times percentage of it plus amount times percentage of it has to equal the total amount I want. I know the total percentage I want for the final solution is 25%, so 0.25. I just need to know what goes here. And I mixed 60 cc's of this with x cc's of this. So the total number of cc's of my mixture is 60 plus x. Here, x plus 10,000. Here, 60 plus x, 60 plus x. So again, there is a direct correlation between these problems. They have amounts, they have percentages, the setup is the same. Sometimes your variables are maybe 10,000 minus x, sometimes they're x plus 10,000. Sometimes the x's are both on one side, sometimes they're on both sides. The individual setup might vary slightly, but in principle the equations are the same. Good. And again, I'm convinced you can all do the algebra from there, so we'll skip off from there. Next up was number 14. A plane travels 800 miles from Dallas, Texas to Atlanta, Georgia with a prevailing west wind of 40 miles per hour. The return trip against the wind takes a half an hour longer. Find the average speed of the plane in still air. So we know this is a distance problem, so I'm going to use d equals RT. Similar to the interest problems. If you know what you're doing, you can just set up these equations like we did with the last two, but sometimes these confuse people, so you can kind of create a little chart. I have Dallas to, where am I going? Atlanta. And then I go from Atlanta to Dallas. And now I want to create a chart. And let's see, I am told, find this, I'm looking at the wrong one, okay? Find the average speed of the plane in still air, which means the speed without the wind. So x equals speed with no wind. And now we established when we did these other ones in the video, I'm going to use that equation. So let's see, what do I know? I travel 800 miles from Dallas to Atlanta. So my distance is clearly 800. My return trip is obviously the same distance, so that's 800. Let's see, the wind is 40 miles per hour, and it's a west wind, which a prevailing west wind means the wind is coming from west to east, which if you think about it means going from Dallas to Atlanta with the wind goes faster, and then going home from Atlanta to Dallas takes longer because you're against the wind. And it says the return trip takes longer, so that makes sense. So then what's my rate of speed? Well, by definition, my rate of speed is my speed in still air. And then when I go from Dallas to Atlanta, the wind helps me. So the speed was 40 miles per hour, x plus 40. When I return, my speed is slowed down by the wind, and it's x minus 40. Now, I need to find t, and this one, and just so we know if you're using these charts, you should never, be plugging in information from the book on this one. This should be based off of the information you already have here. D equals RT. I want to solve for t, so divide the r. T equals d over r. So what is my time here? It's d divided by r. What is my time here? It's d divided by r. Now my chart is full. Now use the stuff in the problem to create an equation. The return trip against the wind takes a half an hour longer, which means the time it takes to go one direction to the east, the return trip takes a half an hour longer. So if I take the shorter trip, going with the wind and add a half an hour to it, I should get the amount of time for the return trip. And there are different ways to write this. You could actually do the return trip minus a half equals that trip, same. But the time to get there, if I add a half an hour, that's the amount of time it took to get home, because this was a half an hour longer. Solve this. The algebra here is a little bit more complex, but we know clear the fractions first. So multiply by the LCM. Do all the algebra, solve it all out. Now again, trust that you can do the algebra from there. The last one really quickly, because we're approaching our 15-minute limit on these YouTube videos. Number 22. Marta can vacuum the house. This is going to be a work rate problem. So we know we create another table, Marta, her daughter, and now the way we set these up, if you want to use a chart like this, first we say the total time to complete the job. And then down here we say together, which is what we care about. And I will point out, you can do this one in terms of hours or minutes. Either one works. If you do it in terms of hours, because of the information given, you'll have to use some decimals, which students generally don't like. So in this case, do the total time in minutes. Marta can vacuum in 40 minutes, so that's just 40. Her daughter takes 1 hour, which in minutes is 60. Together, we don't know how long it takes, so we say X. Now, we say work done in 1 minute. Before, when we did these, we did it in hours, so it was work done in an hour. Since here we're using minutes, it's work done in a minute. And we said the trick was take the reciprocals. If it takes her 40 minutes, in 1 minute, she gets 1/40th done. If it takes her 60 minutes, in 1 minute, she gets 1/60th done. If it takes them together X minutes, in 1 minute, they get 1/X done. And then the setup is the same as before. The amount of work that Marta does in a minute, plus the amount of work that her daughter does in a minute, has to equal the amount of work they do together in a minute. Interest from first plus interest from second is total interest. Mixture from first plus mixture from second is total mixture. Work done by one plus work done by the other is total work. Again, they're all essentially the same problem. Here again, you would multiply by the LCM. 60 and 40 is 120. So you would multiply everything by 120x and then solve. And keep in mind, in this case, your answer X will be the time you want, so that should be your answer in minutes. If you solve this problem with respect to hours, then the X you get will be a decimal, and you'll then have to convert that decimal to minutes out of an hour. Either way works fine, as long as you understand the setup you're doing and set it up correctly. If there are other questions, homework problems, whatever that you want me to go over, let me know, that's fine, and I'll just find time to make even more videos for you.